let me catch up to you in part A. And then I want to give you a little hint about how to make part B a little bit easier. Alright, so part A should be relatively easy. This is a classic problem of this, and I don't mean to make you feel bad if you're having trouble with this. It's all about, can you recognize what to factor, and the problem very often tells you how to factor. So, of course, this factors as those. It almost has to for this. And in real life, that happens more often than you might think. I mean, we're not just engineering these problems to work. They're problems that actually happen a lot in real life. Go into calculus and you're going to have to be able to factor a lot of stuff. And they factor, it just happens. From the real world, it just happens that they're factorable. Okay, enough of that, Jeff. So what's this guy need? X plus 8. And this guy needs? So the two things about this kind of problem is you got to understand why it works the way it does, and you have to accept that it actually is a lot easier than it first looks. Some students just can't accept that it's easy. And I've got to be careful when I say that. Again, but it's easier than it seems. I mean, that was easy. If you can factor, you can see who needs what, and you give it to them. That's almost too nice to believe. And then you multiply by what? X plus 8, X plus 2, so that it just cancels everywhere. So what are you left with?
3x plus 6 equals 2x plus 4.
I like it. In unison. Sound like you pledge allegiance to algebra. Alright. So then you get x plus 4 equals 2 and x plus 4. Subtract x. Subtract 4x is 20. Does that freak anybody out?
No.
I like it. If you would have gotten what? Then you would have had to throw it out.
Negative 2.
-2 or -8. You would have had to throw those answers out. And if those are the only possible answers, there would have been no solution. Which again, students sometimes don't like that. But in real life, if I have a lemonade stand, I know you've heard this before, it took me for math 90. If a lemonade stand, I'm like, let me set the equation up and see what I got to do to make $18 billion tomorrow. I think the equation is going to say no freaking solution, right? I mean, so the real world has situations where there's just no way to get something done. So that's math allows for that in its equations. Yes. Cool. I can do that. Yes, ma'am.
For the answer, do you want us to also include x doesn't equal -8?
No, you don't. But what I'm saying is at the end, don't just circle what you get without thinking about it. If I would have gotten this, then I would have had to throw it out and say no solution.
Oh, okay.
So at the end, you just have to take a second and make sure, is that a number that I can't use?
Oh.
No, so that's a valid answer. I like it. So any problem with the variables on the bottom, at the end, you got to check to make sure that your answer doesn't make anything freak out. If it does, you got to throw it out. It's no good. So now watch. Anybody who's starting to work on this, what's the one part of this that's really kind of, you know already it's got to be something difficult and it's hard to pin down? What part of this? Yeah. The -5, right? And this is x plus 2, x minus 2, but just everybody needs one of those, right? And the middle guy needs both of them. But the minus is going to suck. This is an equation. I could just add 5, and then it's not negative anymore. I don't know why it became Scottish or something. This is an equation. All right, sorry. That's horrible. I can't do accents worth shit. But do you guys understand what I'm saying? If you're like, oh, that negative is going to mess me up. Oh, it's an equation. Let me make it positive on the other side. Shit, yeah, you can do that. It's a freaking equation, right? So if I add 5 to both sides, that looks better. Now I don't have a minus that's going to screw me up. Do you guys see what I'm saying? I mean, the stuff that we learn is applicable in other ways. You can add the same thing to both sides. Yay! Well, hey, there's a really good reason to do it. Totally, I like it. So it's you still have to put a 1 and do the so forth, but the minus is going to be weird when you start to multiply it out. That's where you can make a mistake real easy. So I'm not saying it's not possible to do if you leave it here. It's just the minus sign makes it possible to make more mistakes. All right. So how would you start this off? What's this guy need?
X minus 2.
guy needs x plus 2. And this guy needs, he needs everything. So then I can multiply by x plus 2, x minus 2. Bam, bam, bam. Because this is an equation, I'm allowed to multiply by that. Right? Anything I want to, but that's a good thing. Then I get
4x minus 8.
now here, what is x minus 2 times x plus 2?
X minus 4. X squared minus 4.
X squared minus 4, and then I can bring the 5 through easier, right? So whenever you have 3 things to multiply 2 of them, and then bring the third one in. Is that right?
Wouldn't you like cross out the top or no?
Say again?
You have distributed 5, or could you just...
That's what I was.
I will now.
Oh.
Yeah. So tell me out. What's 5 times? Well, let's see. What's 9 times 2 times 5? Well, I'm going to do this first because that's easy. 2 times 5 is 10, and then it's 90. I'm not going to do 9 times 2 is 18, and times 5.
So because of that, you're not doing 5x minus 10. And then trying
You totally could. Totally could.
Times that by x plus 2.
Totally. And you would get the same exact answer that I'm going to get right now.
Okay.
Right? Because it doesn't matter. If it's all multiplication, then you can do it whatever order you want to. We know that. And again, so if I had to add 2 and 7 and 8, I'm going to freaking add 2 and 8 first and make it 10. Right? I mean, so if it's all one operation, an addition or multiplication, actually, be careful. You can do it any order you want to. It's all on the same level. I like this. So they have that property of commutativity, oh shit, to make it a little more technical, right? Commutative property. Switch around, that's addition and multiplication. Alright. So either way you do it, you should end up getting 5x squared minus 1. So if you left it over here, you should have gotten minus 5x squared plus 1. I like it. Oh, I have no idea yet. I'm nowhere near there. What do I have to do now? And why?
One return.
Sure, okay. So 4x minus 8 equals 5x squared plus 6x. Minus 8. Yes.
So 5x plus 10 times x plus 2.
Sure. 5x minus 10.
Won't I get some x's?
Right? So then you get 10x minus 10x. The middle terms cancel.
No, you can cancel it, negative 8 and negative 8.
I know. I'm sorry. This is a side question. This is going back up to here. So if you bring the 5 in first, so you get 5x minus 10, and then you multiply by x plus 2, the middle terms will cancel. You have to have faith. It will happen. So math doesn't care what order you multiply things in. It doesn't give a shit. So I'm going to multiply the way that makes it the easiest. But it doesn't matter. Whatever way you see, do it that way. I like it. Like you said, the numbers will cancel, right? Because they're going to add 8. Bam, bam. And then I can do what? What do I have to do now? And why? Huh?
Subtract 4x.
Yes, I need to make it equal to 0 because of the squared. So I get 0 equals 5x squared plus 2x. This is where people have creative ways to factor this. But totally. What's going to save your ass is you always try GCF first. You can't do parenthesis here. No, because what comes out? X. I like it. All right, let me stop there for a second. Is everybody cool with this?
And you couldn't add, minus the 6x minus the 4, or does it have to equal 0?
It has to equal 0 because there's an x squared. So I can't get all my x's together, so I need a different process. And the process involves getting it equal to 0 and then factoring. I like it. Because of that, if that wasn't there, I would all day move that over, yeah.
Oh,
Well, I'm still stuck on that 5 times the x squared. Why can't we just write out 5? 5x minus 10 equals 5x minus 10.
Okay. All right. That relates to something I was talking about earlier. So just to focus on the end, it seems to be the part of this that's the freakiest, and I agree. So right here. All right. So just like earlier, I said, do you agree that if somebody takes 2 times 3 times 4, and they tell you it's 6 times 8, what do you think about that? What would you tell that person? Are they on the right track? No, why?
Because 2 times 3 is 6.
And then is there another 2 for the 4? No. So same thing happens, if you put the 5 in here, is there another 5 for this guy? No, there's only one 5.
Okay, got it. Okay.
Yeah.
But why can't you just cross that out like the x minus 2 or the x plus 2?
How do you mean cross it out?
Like how we cross out all the other ones.
Like the other ones, they're the same.
No. Where are the ones that I crossed out?
Numerator spot.
On the bottom. Right. So what did I do? I multiplied both sides by this. Bam, bam. So the top stays. Right? That's the key. This is the right. If I have 3/4 plus 1/2, I multiply by 2, so I get 3 plus 2 over 4. I can't then reduce those. That doesn't work that way, right? Whatever I give it stays there. I had to give it to it for a reason. So I gave this guy these 2 things so that it would have this on the bottom, so that when I multiplied by this, it would die. So those are there. Those have to be there, because I had to give it to it in order for it to have a bottom to cancel. Does that make sense? I can't just go back and undo what I just did. Then I'm like, why did I do it in the first place? There has to be a reason. Yeah. I like it.
So for the first step, I did like as you did before the break. So I multiply the 5 by x squared negative 4. I end up with the same answer, but it was 16.
Well, no. Did you multiply 5 times x squared minus 4? So you get
Because same thing, x squared negative 4 is x plus 2x negative 2.
true. So but it's got to be 5 times that.
Yeah, same thing right here. It's 5 times that.
No.
Because
You didn't multiply the 5 times the negative 4 anywhere else. See that? It's 5 times x squared minus 4. Not 5x squared minus 4. That's different. Yeah, okay. That's different. Did I go again? I know. All right. Okay.
so it will end up with the same answer exactly.
You have to. You have to. And that's what some people love about math and what some people hate about math, is that there's only one answer. To be honest, when you get further in math, you get to the point where, no, there's not just one answer. You get fuzzy math is what people normally know. Chaos theory from Jurassic Park. Remember Jeff Goldblum? You've seen Jurassic Park, right?
Yes.
No?
You know it's not right.
Puts a little droplet of water on there, and he's actually hitting on the girl, but he's talking about chaos theory. Who knows which way it's going to slide? That's the actual thing, chaos theory. So, anyway, sorry. So, yes, no matter what way you pick, you've got to come out to the same answer with algebra. Yes. Is the short answer to that, Jeff. All right.
And so we leave it like that? We don't have to solve for the x's?
Oh, yeah, I'm sorry. I forgot where I was. So, how do you factor this?
You keep going next. 5x plus 2.
So you say either x is 0. Sweet, that's an answer. Or 5x plus 2 is 0. So I'm finally catching up to you. So subtract the 2, divide by 5, so you get negative 2. This. So those 2. Do either one of those make any of the denominators 0? No. If you plug a 0 in, you get 2 and negative 2 on the bottom. Ooh. Right? So only 2 or negative 2, that would make the bottom 0, and I didn't get either one of those. So both my answers are possible. Okay, cool. Let's see an example where I get Let me see if I can find one where I get an answer that doesn't work. So I can talk about that. Here we go. Yeah, okay. Oh, sorry. So P minus 1. Oh, P plus 3. That's a P plus 3 down there. So make this work. Alright, so let's kind of go through this together. I just want to get to the weird point here. First step, factor to see what you're working with. Incredibly enough, it's going to be plus 3 minus 1 to make plus 2 in the middle there, right? Let me stop there. Some of you guys have just a perpetual look on your failing. So I got to remember that so I don't feel bad when I look back at you. Alright, so this is not too bad, right? Who's missing something? Is he missing something? Yeah, he's missing a P plus 3. He's missing P minus 1. And he... Nothing. He's got everything. It's good for him. So then I can multiply by P plus 3, P minus 1. Alright, let me stop there for a second. So all the bottoms just went away. So what am I left with?
P plus 3
P plus 3
minus P minus 1.
Minus P plus 1. That stupid minus, right? So from the very beginning...
I was talking in parentheses.
Oh, I got you. I didn't hear those parentheses. You could have added this over if you really wanted to. The process doesn't change. So if there's ever any minuses in these equation problems, you could totally add them over so that they won't mess you up. You can't do that in 7.4 because there's no other side. There's no equation. So you're stuck with it. If you have no idea what I just meant, just leave it like that and be careful with the negatives. Equals 1. So what do I get? I get
4 equal 1.
I get, yeah, exact thing. I get 4. I was hoping this would come out a little bit different. So that's one way this could come out. We know what this means, hopefully. I did not just prove that 4 is 1. Thankfully, you owe us $4,000. No, just 1,000.
5 equals 0.
5 equals, well, 3 equals 0. Right? You would subtract 1, you get 3. Anything you get is going to be, when is it true? So when x is 0, then this equation is true. That's what it means. So when 4 equals 1, then this equation works. Well, when is 4 equal to 1?
Never.
Every other third? No, never. Therefore, this equation never works. So what's the solution?
No solution.
No solution. So the other way to have no solution would be if I get p equals 1. Why is that no solution?
Because
Yeah, it makes one of these undefined. So I would have to throw that. There would still be no solution. So either it's very direct in your face. Well, that can't work, so that can't work. It's no answer. Or it looks like there's an answer, but shit, it makes that 0. Right? That's the two ways you can get no solution here. Now, real quick, my Math 90 students, you've heard this before. It's not math's fault. If I do get this, and I did everything right, and you're like, stupid math, I did everything right, and you tell me this isn't right. Well, what did we do right there? We multiplied by p plus 3, p minus 1. If p is 1, what did I multiply by? 0. Am I allowed to multiply by 0? No. So I did something I wasn't allowed to do at a time when I didn't know it was not allowed. So this is math going, shit, dude, you did something. So math is trying to be nice to us. All right, dude, if you can do that, I can do this. We're like, oh, shit, I can't do that. No solution. Hopefully that made some kind of sense. You just, at the end of these problems, you got to make sure it doesn't make something undefined. If it does, throw it out. I like it. So you could get one that works and one that doesn't work. You throw out anything that makes it undefined.
So what would this question be asked for us
Solve.
to solve?
Yep, cool. Okay. So let me do this. Well, let's see what you guys know already. And this is good. I'm trying to figure out which order I want to do what I want to do now. Let me give you this here before anybody escapes. On one side, there's the practice test. I'm going to have the answer key for it next week. On the other side, there's a little worksheet that relates to section 8.1. It's the same function worksheet I used from the Net 9 class. Yes. Yes. Well, I was going to bring it up there. Very full row. Alright. So, very quickly about this first. The practice test, you don't have to do any of these if you don't want to. It's just a study guide. This is here, so you can kind of see the way I set up my tests. And then the answer key will be given to you next week. If you don't have time to do any of these, understood. Right? You should focus on the homework. Make sure you do some out of each section at least if you get a little behind. The other side we'll talk about in a minute, about the functions. On Monday we are having that quiz, the next quiz, and it's going to cover it's basically going to cover 7.1 through 7.3, because that's what we got through yesterday. So I don't know if you picked up on what I said before. I never quiz you on something we only got into the day before. It's always at least 2 classes later. So you have had time. Maybe you didn't do it, but you have had time to get to the homework. Okay. So this is just, reducing rational expressions. Where is it undefined? And then combining things with like terms, like denominators already. That kind of thing. Cool. So let me see what you guys already know about functions. So if I write, alright, let's start off here. So you can have a relationship between 2 variables. So for example, there is a relationship between the number of hours I work, if I work at a gas station or something. That was my first job. I was making $3.15 an hour. Oh yes, living it up. There's a relationship between the number of hours I work and the amount of money I get, right? Of course there is. And in fact, it is the 3.15 number that is that relationship. Are you with me? So there are relationships between variables, but then we want to be specific about a certain type of relationship. We want to say, if I throw a ball to somebody and I say 5 seconds later, where is that ball? And they say, it was 20 feet up in the air and it was 5 feet below the ground, I'm going to be a little freaked out. Or if I ask somebody, what size shoe are you wearing right now on your right foot? And you say a size 3 and a size 4. What is happening? You have 2 shoes on. You guys understand? So I want to say a subset of relationships. There's all kinds of relationships between variables. I want the ones where it makes physical sense. I'm going to call those functions. So for every question I ask you, I want there to be only one answer that you can give me. Right? So like the ball can't be in 2 different places at once. Was there some samurai in there chopping my baseballs in half? Oh shit, we got to go to some other park that has a few less samurai in it. Alright? Samurai just come in. Alright. So a function, the definition of a function. Anybody ever heard of Highlander? Highlander, okay, good. You'll get this. You'll get this. The rest of you just, this is the function, so it doesn't matter. This is the definition. For every input, and inputs are normally X.
There can be only one.
There can be only one. Only one output, which is normally Y, but it didn't have to be. Like we've already seen, the input could be T and the output could be H. The input could be time and the output is height. Right? We saw a function that did that. But normally input's X and the output is Y. How are we doing so far? I mean, that's, nothing about Highlander, you're fine. You don't have to know. It's not a prerequisite for this course to watch that, but you should go see it anyway. Maybe not the second movie. I don't know. Okay? So, how does this relate to things in different formats? So visually, what does this mean? Would this be a function here? Yeah! So, for this x, how many outputs are there? 1. So far, everything's great. Where do things break down? Right here, for example. For that x, if this is time, at this time, where is the rocket? Well, it was here and here and here. Well, something has happened bad. Something bad has happened. Do you guys see that? So for every input, there can only be one output. But how many outputs are there for this input?
3.
There's 3. All it takes is more than one. If there's more than one output, the thing is screwed. It can't be a function. It can't be what we call a function. All right, I like it. So visually, it's just any graph that just doesn't come back on itself like that. So how about, is this one okay? Is this a function? Yes, totally. Right? Every single x only goes to one output. So it passes the what test? Vertical line. So this does not pass the vertical line test, right? The volt. So this is not a function. But this one, every vertical line I can imagine only goes through it once. And why does that make sense? Because a vertical line relates to an input. And if it only goes through it at most once, that's only one output then. This went through 3. Oh shit, 3 outputs. It's dead. I like it. How we doing? Okay. Does this sound familiar? This should be about where you ended up if you took Math 90 here. Okay. So the other kind of idea that relates to another way to write a function is the ideas of domain and range. So what is the domain of a function? What does that mean? Something about the x's. Be a little more specific.
X-axis.
It's not the whole x-axis, right?
Location.
It's all the x's that... You can do it. So, if I had this function here, you could do it, Jeff. So if I had this function here, what would the domain be?
-1.
Yeah, why is 2 not included in the domain? Because 2 does not have an output. Good. So domain is all the x's I'm allowed to use, or alternately, all the x's that actually have outputs. Right? So the domain of this would be -2 to 1, because that's the collection of all the x's that actually go somewhere. They're all the x's I'm allowed to use. If I say, well, use 2, I can't. I don't know where 2 goes. Shit, it didn't tell me. Maybe it suddenly turns, right? The stock market. Let me put a lot of money. Oh, shit. I don't know what it's going to do because it didn't tell me, so I'm not allowed to use that. So the domain is a collection of all x values that actually have outputs. So here the domain would be -2 to 1. And this notation, what is this notation? Interval notation. This means it's everything from -2 to 1. All the numbers. Because every single number in between goes somewhere. I like it. So then what must the range be then?
The y.
Yes. It's a collection of all, it's trying to be a letter C, collection of all y values that actually occur that are outputs. You can spell, Jeff, can you? That's a good question. Outputs. So what would the range be for that one?
0?
Good. The smallest output is 0. So now you look at the y-axis. You have a little dude. This is how I sometimes say this. Have a dude walking on the y-axis. What's the first time you see something at 0? And what's the last time you see something at 2? So the range here would be from 0 to 2. That's all. That's a collection of all the possible outputs. And the domain is a collection of all the possible inputs. I like it. So I know what you meant when you said x-axis. I just was trying to pull more out of you. Yeah. All right. So let's do a problem. Let me try to stop talking.